Hi, I'm Jeff Gagno, Product Manager here at Neo4j. Thanks for taking the time to join me today, where we'll talk about datetime features in Neo4j Bloom. Neo4j Bloom is Neo4j's graph visualization solution, and we've introduced some new features as of Bloom 2.1 that enable the full suite of editing capabilities for datetime types, as well as the ability to conduct easier analyses with these types using Translate Time Zone 2 and other filter and rule-based styling features. Let's get started. Imagine we have this data set that represents IP addresses for an internal network for a global organization on the nodes and summarized traffic flows between them. For now, let's have a look at one of the IP address nodes and just quickly recap some of the different datetime types in Neo4j. There's a time type shown here, as well as a local time, which is the same as time but doesn't include a time offset or time zone. We also have a date time, a local date time, and a date. There are only two data types in Neo4j that include time zones or time offsets. Those are the date time type, as well as the time type. Neo4j Bloom now offers the ability to directly edit these types directly in the interface, and it includes both convenient datetime pickers as well as the ability to directly edit the data by entering the values as you wish. Let's imagine that in this data set we have data representing traffic collected from 4 different points in our 4 international offices of this imaginary organization. Imagine that we have offices in San Francisco, where the time zone is expressed as GMT-8, Ottawa, Canada, with time zone GMT-5, London, England, with time zone GMT, or Z for Zulu time, and Malmo, which is in time zone GMT+1. This table shows that for different times of day in California, so start of business at 9 o'clock, lunchtime at noon, and close of business at 5 o'clock, we can see the associated local times at that point in time for all of the other offices. Time zones are not always intuitive, but Neo4j Bloom has made it easy to understand and analyze data that involves time zones across multiple different regions. Looking more closely at our data, we can see that the traffic flow relationships contain dates and times, including a time zone value. We also see that they've had a rule-based style applied that alters the thickness based on the number of forward packets. In this scenario, all of the times associated with traffic flow relationships have a time zone, and the time zone relates to the office in which the traffic was collected and summarized. In this situation, we might be interested in looking at just traffic flows that occurred before 9 o'clock local time. So to do that, we'll open up Bloom's filter panel, and you can see that as we adjust our settings, we can see relationships that fall within the time range we've selected. Here, I'm going to choose before and set the time to 9 o'clock local time. Even though all of the time zones on the relationships in this scene have time zones associated with them, by default, Bloom will ignore the time zone and it will show just relationships that occur before 9 o'clock. In this example, we have 3 o'clock and we see that this time zone was GMT or Zulu. Now we can have a look at all of the relationships that represent traffic flows that occurred before 9 o'clock in local time, regardless of which office they were collected at. Now let's imagine that we want to answer a different question, and we're interested in something that happened at around 11 o'clock local time in the London office. You see that we have this Translate Time Zone 2 feature in Bloom. If we select this, then you'll notice that the parameters of the histogram have changed on the top left and right to show beginning and end times represented on the scene in GMT time. We can change the time offset to whatever we like, and if we look at GMT+2, for example, you'll see that the histogram shows the start and end time relative to GMT+2. Note that nothing is changing the data in the database or really in the scene. We're just looking at our filter through the lens of the time zone of our choice. In this case, since we're interested in something that happened in the London office between, say, 10:55 and 11:08, we'll translate time zones to Zulu time, or GMT, and we can quickly see just the traffic flows that occurred at these times. We can verify this is the case by looking at a relationship where we see that something occurred at 3 a.m. in GMT minus 8. That indicates the California office. And of course, if we add 8 to 3, that occurred at around 11 o'clock British time. This makes it very easy to use Neo4j Bloom to do time-based analysis from the perspective of any time zone of your choice or from local times, ignoring time zones, without altering any of the data in your database or needing to run complex procedures on your data before conducting your analysis. Well, we used Bloom's filter feature to demonstrate these capabilities, including the ability to translate time zones to a time zone of your choice. These capabilities all exist within the rule-based styling of Bloom as well, making it easy to style relationships or nodes based on time values using time offsets of your choice by translating to or using local times and ignoring the time zones that might be present in your date, time, or time data types. Thanks again for taking the time to review this video, and feel free to get started with Neo4j today by going to neo4j.com and clicking on the blue Get Started button.